Lastly, we're going to talk about hierarchical routing, which is kind of going to be telling you how things actually work in practice as opposed to these sort of theoretical routing algorithms. Our study of routing thus far has been an idealization of the way things actually work. So I've sort of lied to you in that this isn't how it really works. All routers have appeared to be identical, and we've been in one big flat network where a router was routing for all the routes in some global one network. That's not the way the real world is. Two problems with that. One is scalability. The size of the internet is so large that we can't have one router that knows the cost to every other router in the internet. It's too large for that to work. Can you imagine how many messages you'd have to send if you had to, for link state in particular, if you had to send a message to every other router in the whole internet? It would be impossibly large. So what we're going to do is we're going to divide up the internet into other networks. And inside those networks, we'll route. And between those networks, we'll route. Right? But at different levels. Another big issue here is administrative autonomy. And that means people, companies, countries want to have policies that need to be enforced in the network. So one company may want to, well, imagine at the country level, the United States of America may very well not want to have any routes that go through China, right? Even though it might be faster, maybe in some way, for us to go from point A to point B, both inside the U.S. to go through China, although that's possible based on the conditions in the internet, right? There might be policies that we'd never want that to happen. So it's not always about shortest path. Sometimes it's about policy that determines what routes should be created. You can imagine the same thing with just AT&T and Verizon. Maybe they're not going to, unless they have a deal with somebody, they're not going to send their information over somebody else's network. Okay, so what is the truth? Here's the truth, right? You can handle the truth. Generally, you have a gateway router, which is your first hop router in your network. Right, so that's kind of the closest you get to the router. Routers are organized into autonomous systems, AS. So an autonomous system is this big word for this group of routers in a region. Okay? Routing is accomplished inside that autonomous system with intra AS routing protocols. So routers in the same autonomous system have to run the same routing protocol. Yeah? But routers in different autonomous systems could run different routing protocols. So if Freed wants to run RIP in their network, in our network, they can do that, and Harding can run some other routing protocol. It doesn't matter because we don't have to route among each other within the autonomous system. Yeah? Inter-AS routing protocols, those are how the autonomous systems connect to each other. And that still has to be one routing protocol. But this is the routing protocol that everybody has to follow if you have this kind of exterior router. Okay? So when you have interconnected autonomous systems, it might look something like this. You can see we've got 3 autonomous systems, and each autonomous system has, 3 or 4 routers. The forwarding table in routers have to be configured using both the intra and inter AS routing algorithms. So if you're going from 1A to 1B, you're going to be using routes that are set up in your forwarding table using the intra autonomous system routing algorithm, right? Whereas if you're going from 1A to 2A, you're going to have to know how to get to kind of an external router. And you're going to have to use your forwarding table is going to also have to be configured with whatever routing algorithm is used between autonomous systems. So if, no, that's basically what we said. These routers that connect to other autonomous systems are called gateway routers. And so you're going to have to use those if you have an external destination. I'll leave these slides in here and you can go back and look over them if you want. I'm not too heavily concerned about this. The idea is here that we are hierarchically arranging autonomous systems, which are groups of routers. And it's almost as if then the routers that are on the edges are, they have to run a different protocol and communicate with different people to connect between autonomous systems. You can imagine in this case, getting from from 3 to 2, you may even have to choose between routes in autonomous system 1 or this autonomous system X. And it's almost in that case, you could imagine this whole blue area kind of being a router in our previous discussion where we were routing between places. Within an autonomous system, you're probably most concerned about what's fastest. Yeah? Between autonomous systems, policy decisions may be the most important. And it's not about the shortest path, but it's about who you've agreed to send, who lets you send their traffic through based on organizations or countries or whatever. So the inter-AS routing protocols and intra kind of serve different purposes, but they allow us to break the internet into manageable chunks, and routing happens within those chunks and between those chunks, or among those chunks. The questions on this hierarchical routing issue. All right, next time we're going to look at 4.6 and maybe a little 4.7 and talk about how routing actually happens in the internet. And we'll look at a little of the details on these 3 protocols and the RIP, OSPF, BGP. These are protocols that are one of these 2 types, link state or distance vector, but they're used in different scenarios. Like I think these first 2, RIP and OSPF, are used inside an autonomous system. BGP, the Border Gateway Protocol, is the routing protocol that has to be used between inter-autonomous systems, right? And you have to use that because everybody has to run the same one. So that'll be a good discussion next time. Look forward to that.